How are you doing, math learners? This is your free access math teacher Ash, and welcome to ML with Sir Ash. Today, we're going to discuss problems involving sets with the use of Venn diagram. So, hit that subscribe button and notification bell, and get ready for more cool math learning videos just like this. So what's up, math learners? Today, we will be discussing Math 7, Quarter 1 of Week 2, entitled Problems Involving Sets with the Use of Venn Diagrams. So our learning objectives for this discussion are the following. We will illustrate set statements involving two sets with Venn diagrams. We will also consider the tree set with Venn diagrams, and we will solve problems by using Venn diagrams. So now, let us start first with the two sets with Venn diagrams. Now, illustrating a two-set statement with a Venn diagram. We have here a Venn diagram with two sets. This rectangle represents the universal set, and we have two circles that represents the two sets. Now, we have the Roman numeral 1, 2, 3, and 4, and this will represent our region. So, this first region will represent the elements in set A that are not in set B, while this middle region, the region 2, will represent the elements that is in both set A and set B, while region 3 will represent the elements in set B that are not in set A, and finally the region 4, which will represent the elements that are in the universal set but neither in set A nor in set B. Okay, so that is very clear. So now let us consider some steps in using Venn diagrams with two sets. The first step is that we will find the number of elements that are common in both sets and write that number in the region 2, so in this middle region. Next, step 2. We find the number of elements that are in set A and not in set B by subtracting the number in region 2 from the total number of elements in region A. So, technically, this is the cardinality of A minus the intersection of A and B. Alright. Then, we will write it in the region 1. Next, we will just follow the same steps in this third region in which the set B, the cardinality of set B, subtracted to the cardinality of the intersection of A and B. And that is what we will write in region 3. Now, step 3. We will find the number of elements in U that are not in either A or B and write it in the region 4. So, we will write it in this outer sets. Okay. And last step, we will use the diagram to answer specific questions about the situation. Now, let's consider a problem. Okay, example number 1. In the 50 states of the United States, there were 36 states that had some form of casino gambling in the state, 42 states that sold lottery tickets of some kind, and 34 states that had both casinos and lottery. Now, draw a Venn diagram to represent the survey results and find how many states have only casino gambling, how many states have only lotteries, and how many states have neither. Okay, so step 1, we will draw a Venn diagram with our Roman numerals representing the regions of our sets. Okay, step 2. We will put our value 34 in the intersection of the casino and the lottery, which is in region 2. That is 34, right? Now, knowing that we have 36 states that have casino gambling, therefore that 36 will be subtracted to 34 in order to get the region 1 value. Okay, and that is 2. So we write 2 in our region 1. Next, we go to the region 3. Since 42 states have lotteries and we already have 34 in our middle region, so that 42 will be subtracted by 34 and the answer is 8. And this 8 will be the value in our region 3, representing that there are only 8 states that focuses on lotteries. Okay, and then now we go to step 4. Now, 44 states are already accounted for. Because if you add 2, 34, and 8, that is 44. So since the United States have 50 states, we only have 6 more or 6 left to put in our region 4. And that completes our figure for the Venn diagram. Now, let's answer the problem. There are only 2 states that have casino gambling, but no lottery. There are 8 states that have lotteries but no casino gambling, which is in region 3. And just 6 states that have neither. So we have answered our problem using the Venn diagram. Now let's consider another example. In a survey published in the Journal of the Dermatologists, 500 people were polled by random telephone dialing. Of this, 120 reported having a tattoo, 72 reported having a body piercing, and 41 had both. Now, draw a Venn diagram to represent these results and find out how many respondents have only tattoos, only body piercing, and neither. Okay. Now, solution for that is the same of what we did in the example number 1. We will draw a Venn diagram representing our tattoos and body piercing. Okay. With the regions 1, 2, 3, and 4. Okay. Now, let's start with the middle. So, it has been said that there are 41 respondents that have both tattoos and body piercing. So, we put it in our middle region. And then, it has been said that the number of people with tattoos are 120. So, we subtract 120 to our 41 and we will have 79 people with only tattoos. And that is for region 1. Now, let us go for the body piercing. It has been said that in the body piercing, there is a total of 72. However, since we already have our 41, so that 72 will be deducted with 41 people, giving us 31 people as people with only body piercing. And that will be the value in our region 3. Now, let us consider if there are any more people who have no body tattoos or body piercing. Now, since there were 500 people that was called, we will add 79, 41, and 31, and that gives us 151. That 151 will be subtracted from 500 people accounted, so therefore, 500 minus 151 will give us 349, and that 349 will go to our region 4. Now, let us answer the problem. There are 79 people with only tattoos, there are 31 people with only piercings, and there are 349 with no body tattoos and body piercing. So now let us consider Venn diagrams with 3 sets. So 3 sets represents 3 circles. So with these 3 circles, we will have 7 regions in all. The region 1 will represent set A but not in set B and set C. The region 2 will represent set A and set B but not in set C. Okay, this one. Region 3 will represent our set B but not in set A and set C. So this is exclusive for set B. Region 4 will serve as our elements in set A and set C but not in set B. And then we have region 5 as a representation for our elements in both 3 sets. Okay, so this is the intersection of the 3 sets. We also have region 6 that represents the elements in set B and set C but not in set A. And now we have region 7 that will represent our elements in set C but not in set A or set B. And finally, that will represent our elements in the universal set but do not belong in set A, B, and C. Okay, so now let's consider a problem. A survey of 300 first-year students at a large state university was conducted to aid in scheduling for the following year. Responses indicated that 194 were taking a math class, 210 were taking an English class, and 170 were taking a speech course. In addition, 142 were taking both math and English, 111 were taking both English and speech, 91 were taking both math and speech, and 45 we're taking all three. Now, draw a Venn diagram to represent these survey results and find the number of students taking A. Only English, B. Math and speech but not English, C. Math or English, and D. None of these three subjects. Okay. So let us remember we have 300 first year students. Okay. So we have here our given 300 students, 194 for math, 210 for English, and 170 for speech. 142 for math and English, 111 for English and speech, 91 for math and speech, and 45 for all three. Okay. So first we will draw our three sets. Okay. That represents M for math, E for English, and S for speech. Now, step 2, we will start in the middle of our region, which is region 5. So, since this is the intersection of the three sets, we will put 45 in this region. Okay. Now, let us consider to the intersection of two sets. There are 142 students taking math and English. Math and English, alright? There are 42 students taking math and English. Since we have already 45 here, we will subtract our 142 to our 45 in order to get the value in region 2. So that is 97. So we will put 97 in our region 2. Now, continuing step. In the same way, we will get 91 students for math and speech. This is the math, this is the speech. So this is the intersection of math and speech, alright? So in the math and speech, there are 91. However, we already have our 45 students. So again, we subtract 91 to 45 and that gives us 46. And this 46 will be the value in our region 4. Okay, same goes to our English and speech with 111 as total. And we will subtract 45 from 111, giving us 66 students for our region 6. Okay, so we already answered values in our intersections. Now, let us go to our exclusive values. Okay, now let's continue. Since our mathematics is 194, our English is 210, and speech is 170, then what we will do is, first, we will add 97, 45, and 46, and then the answer of that one will be subtracted to our total math, which is 194. So by adding 97, 45, and 46, we will get 188. And then that 188 will be subtracted from 194, giving us 6 students. Alright, so that is the value of people that are exclusive for math only. Now, let's go to letter E. Now, for our English, we have 210 students. The 210 will be subtracted to 97, 45, and 66. So, in order for this to become easy, we add first 97, 45, and 66, which will give us 208 students. So, that 208 will be subtracted from 210, and then the answer of that is 2. So, therefore, there are only 2 students exclusive for English only. And finally, we go to our speech. Our speech is 170. So if this is the circle, we will add 46, 45, and 66, giving us 157. So that 157 students will be subtracted from the 170 in the speech set, which will give us 13 students in region 7. Okay, so now, can we know the value of our region 8? Okay, so what we will do here, in order to get the value in region 8, we will just add all the values in our 3 sets and we will subtract it to our 300 students. Okay, so continuing, we have the step 5. So by adding all the 3 sets, we have 275. Since we have 300 students, that leaves us 25 students in region 8. And that answers our Venn diagram. So now, let us proceed to answering our questions. Students taking only English, and that is 2. Alright. Math and speech, but not English. Math and speech, but not English. Okay, so not English. This is our region 4. So that is 46 students. Students taking math or English. Math or English. So this is math and this is English. So what we will do is we add 6, 97, 45, 46, 66, and 2, and that give us a value of 262. Or in a simpler value, we just get the complement that do not belong to the math and English, which is 25 and 13, adding them and then subtracting it from our 300. Still, we will have 262 students. Okay, and finally, there are only 25 students outside the regions of all math, English, and speech. And that answers our letter D. So hopefully you have understood this discussion. Now, this is the time that I will be giving you your exercises. So let me challenge you with this. Try these questions. In a group of 100 persons, 72 people can speak English and 43 can speak French. Question: how many can speak English only? Second question: how many can speak French only? And last question: how many can speak both English and French? Next, among the 70 kids in Barangay Magana, 53 like eating in Jollibee, while 42 like eating in McDonald's. Question: how many like eating both in Jollibee and in McDonald's? Question 2, how many like eating in Jollibee only? And question 3, how many like eating in McDonald's only? Okay, that is for our 2 set problems. Now, let's have our 3 set problems. A group of 50 students went in a tour in Palawan province. Out of the 50 students, 24 joined the trip to Coron. 18 went to Tubataha Reef. 20 visited El Nido. 12 made a trip to Coron and Tubataha Reef. 15 saw Tubataha Reef and El Nido. And 11 made a trip to Coron and El Nido. And 10 saw the 3 tourist spots. Question: how many students went to Coron only? Question number 2, how many of the students went to Tubataha Reef only? And question number 3, how many joined the El Nido trip only? There's still a question number 4, how many did not go to any of the tourist spots? So hopefully you have understood our discussion about using Venn diagrams in solving problems about sets. This is your free access math teacher Ash, and always remember that it is fun to learn mathematics if we are together learning. Thank you and God bless.